My name is Bolaji Olajide, as they introduced me. Yeah, so why we're here? I'm here to talk about writing efficient code with Python Decorators. Python Decorators have been a thing for a while, and I just want to show us the benefit of using Python Decorators and what they can do for us, the benefits also, sorry. About me, my name is Bolaji Olajide, software developer at ANDELA, and I'm a Pythonista, and I also work with React.js occasionally. I contribute to several open source projects, like Balrog from Mozilla, and also some from Nigerian developers. I'm also a writer. I have a Medium publication called Backticks and Tildes, and I write posts for myself on my personal Medium account. And most people know me as Proton. Is a nickname I got when I was in secondary school. Positivity. Yes, I just want to talk briefly about ANDELA. ANDELA is, I think, fairly popular. Most people know about it, and I just want to just give a brief description of what we do at ANDELA. So what ANDELA is about is looking for the brightest talent, giving them access to resources, structures, and mentors to enable them own the software, the craft of software development. That is basically all that we do at ANDELA. And the mission is that we believe brilliance is evenly distributed, but opportunity is not. And what we do is we bring that opportunity to developers that are interested, and we help them become world-class developers. Now on to why we are here. Code efficiency. Sorry, has anybody ever used a BBM before? A BlackBerry phone, sorry. If you have used a BlackBerry phone, can you raise up your hand? Now, you agree with me that one major problem that BlackBerry phones had then was the fact that it was always hanging. Like, you might just want to call your mom that you need money, and the phone will just be hanging, no matter how urgent it was. Now, what is efficiency? Efficiency has to do with delivering of maximum productivity with minimal wasted effort. And it might be shocking that people don't believe that your code can actually have wasted effort. I mean, like, there are some things that your code does that it doesn't need to do. Now, when it does this, it wastes more time, which, okay, let's take, for instance, you go to a website like my personal website, and you find out that you have been there for 2 minutes and it's still loading. The more time goes, the more you lose interest in what I have to offer. If it takes too long, you might even be so angry that you just close up the website and like, why do I have to be here? That's what I'm going to talk to you about. Achieving maximum productivity with minimal wasted effort. Now, when you say code efficiency, there are two things that code efficiency entails, which is, number one is speed. Speed being that we all want things to work fast. Like, when you open google.com, you see that it takes you like about less than a minute to open, and you have your search engine that you can search for anything. But when you are done searching, you see like you're searching for, let's say, Facebook, and you now click on the Facebook link and it's taking you 5 minutes. You get bored, like, why do I have to wait this long? And that is because the site is not efficient because of the code. The second point that code efficiency talks about is reliability. It's not just enough for your code to be fast or your product to be fast. It has to be reliable. What does this mean? Like, no matter the weather, it should always deliver. Like, even on slow internet connections, you see several websites nowadays, they even provide offline access. Like, even when you are offline, as far as you've downloaded the page on your system, there are some pages that are cached into your browser, which you can easily open to access. So when you're on like 2G connection, as far as you can open the home page, you can easily access other pages. Why do they do that? Because they want their website to be reliable. Okay, the third point is high performance. Now, when you build a product or you build an application outside, you always want it to perform well. You want it to be scalable. You want everybody to be able to use it. Like, if you build an app for, let's say, a GIS app like the previous speaker talked about, and you discover that like once the number of users on the website are above 10, it starts slowing down. That is not high performance, which means it's not reliable. So these are the three main things that code efficiency talks about: speed, reliability, and high performance. Now to demonstrate this, I want to talk about why your code should be efficient. And I will give a simple illustration of why it should be. Now, let's assume I have a list of objects in my bag. The first list contains weave on, wig, clipper, headphones, and bag. I don't have that in my bag though. It's just there. So now you have another list of things, let's say in your neighbor's bag, which contains clipper, headphone, iPod, wristwatch, and weave on. Now, if you want to compare what is inside these two bags, now, off the top of your head, I don't expect someone to say, okay, let me first take weave on. Now go to the person's bag and check, is this weave on? Is this weave on? One by one. Like, you pick out the first item, check, is clipper weave on? Is headphone weave on? Now, imagine you have like 100 items. Imagine the time you'll have taken to go over to check what things are in bag A and also in bag B. Now, off the top of your head, if I ask you now, do you have a phone? You already know that you have a phone. You don't have to empty your pocket one by one to know that you have a phone. Now, that is where code efficiency comes to play. I'll be displaying two code snippets here. They are sample functions that they both do the same thing. Check the common items in two lists, which in Python are known as arrays. Checking what particular items are common to both of them. Now, the first one makes use of a for loop, a nested for loop, which is very dangerous in my own opinion. Now, it checks each of the item. It takes one item in the first array and checks manually for the second to check each item of this in the second one to see which one is common to both of them. Now, this will give you your desired result. I mean, at the end, you will get what you want and you will get the right answer. But imagine where you have like a list with 100 items. One has 100 items, another has like 800 items. Now imagine how long it would take you. If you try and run this code with a list that contains 100 items, you see that like you have to wait for like 5 minutes for you to get a response. Now, the second function does exactly the same thing. The only difference is that like this makes use of something in Python called list comprehension. Now, as I said before, if you have a phone with you, and I ask you, do you have a phone with you? You don't have to empty your pocket to let me know that you have a phone. You already know that you have a phone. That means you have like a snapshot of what you have with you. Now, that is what list comprehension does for you. It already knows what is inside the array, so it just asks it. That is why you see item for item in array 1. That is for every item in array 1, if the item is in the second array, it should add it to another array, which is what you are returning at the end. So you don't have to manually go through each of the items one by one. And with this, in 2 seconds or 5 seconds, you get your result. Even when you have for like 1,000 items, the time taken is not as much as the first function. Now, decorators. What are decorators? Decorators might seem complex at times. Some people say they look like jargons because of the way they look like sometimes. But a decorator is simply a function that takes in another function. And what it does is it extends the functionality of a function without explicitly modifying it. Now, I know I've used the word function too many times, but that is the best way I could describe it. Now, let's assume a function. You wrote a function that makes me walk from here to here. Now, that is all the function is meant to do. And using the design patterns we learned yesterday, I think one of the speakers explained something like this solid principle. A function should be able to do only one thing. So that if you have a function to add 2 numbers, it should not do more than add 2 numbers. Because you see several people using writing functions that does more than what they should do. When you write a function, it should do only one thing, and that is what you have told it to do. So you have a function that enables me to walk from here to here. But now you want to extend the functionality in that if my mom tells me to walk, if my mom runs that function, Instead of me to walk from here to here, I should walk from here to there. But if any other person calls me, I should walk from here to here, and more like that. But you don't have to directly modify the function which you have written. That is the one function. You can actually use a Python decorator to extend its functionality without modifying it. Now, why Python decorators? Python decorators can be used for analytics and logging. You want to check how much time something takes to, how much time I take to even start working in the first place. You want to check, you want to log the exact steps I'm taking, the exact coordinates of the exact places I'm stepping on before I get to my destination. You can make use of Python decorator. Validation and runtime checks. Now, you need to validate if it's my mom that called me or if it's someone else that called me. You don't have to do that in your function, because your function should only do one thing. That is, make me work from here to there. Now, you can do this validation and runtime check inside your Python decorator, and you've abstracted everything out so that what a user sees, what a developer sees when he opens that function is just work from so-so place to so-so place. Now, code reusability. With the use of Python decorators, you can use the same function that you have written in several places, because the function, which is to make me work from here to here, can be used in multiple places. And that way, I don't have to start removing if-else statement and now adding more conditions for the function to go through. Now, the last reason is for writing cleaner code. I mean, wouldn't you like to just see a function that just does one thing and it's just in 4 lines and it does what it's meant to do appropriately? We don't have to see like 100 lines because of you want to check if the person is logged in, you want to check if the person is my mother, you want to check if the person is my girlfriend, you want to check if the person is my teacher or something. And yeah, decorator use cases. If you've been working with Python for a while, especially with frameworks like Flask and Django, at least once in your development career, you would have made use of a Python decorator. I mean, in Flask, to define your route, you can make use of a Python decorators. To define static methods, class methods, you actually make use of a Python decorator. So we use them, but we use the defined ones. And what I hope to take us through today is how to make your own custom decorators, which can do what you want to do. Yes, they are hot right now. And this is the basic syntax for a Python decorator. Is simply a function that takes another function. As you can see, we have the outer function, which is the decorator function, which is wrapped in the wrapper function, and at the end is returning the wrapper function. So before going into a demo, I just want to show you how to make analytics with decorators. This is a simple code snippet, and what it does is check how much time your function takes to run. Now, the main function is the one that is defined below, which is def my function. But the timing function decorator is just used to check the time at which the function starts executing and the time which it does, to know how long it takes. So you want to know how much time that for loop function that I wrote, the nested for loop, you want to see how much time it takes when you have like 100 items in an array, when you have 50 items, you want to compare them. You can make use of Python decorators to get that answer. Now for a little demo. It's crazy. Yeah. Can you guys see? Can you guys see? You can see, right? Okay. My desktop. Is it working now? You can see my screen? Nice. Okay. Now, I'm going to make use of a Python notebook just to show you guys what a decorator can do. Now, I'm going to be working with this function. This is a function that just returns the addition of 2 numbers. Like when you pass in 1 and 2, the expected result is to give you 3. Let's see how that works here. Now, if we add 12 and 12, we get 24. But now, we want to modify this function in such a way that instead of just giving us the output, which is 24, we want it to customize it and return let's say a dictionary that shows us the first argument, the second argument, then the result. Now, you don't have to start writing all that inside here. You can abstract that into a decorator, which is just a sample decorator that I want to show you. So, I'm calling the name of my function JSON, and I will explain everything I'm doing here. I just want to do this. So I have my sample decorator here, which what I expect is for it to return a JSON object that includes the first argument, the second argument, then the result. Now, I want to explain everything that is going on here. From the first line, all I just did is define a function and call the name of the function JSON. And what I'm passing into it is the actual function that I want to override or I want to extend its functionality, which I'm referencing as f, yeah? Then I'm defining another function inside, which contains the arguments, which is what you are passing into the function, which is your a and b that you have passed in here. Now, once that is done, I have access to the function and the arguments here. Then I'm taking each of the arguments and assigning them to a key in the dictionary that I just created. That is the empty dictionary here. And I'm getting the response of this, I'm getting the response of this function by calling the function and passing in the argument here, which is just like doing what you have done before, but just modifying it now. Now, once that is done, I can decorate this. This is how we make use of a Python decorator. You just use the @ symbol and call the name of the function. Now, the name of this function is, the name of the decorator is called JSON. Now, when I run this, and I come back here to run this, you can see what I get. I get a dictionary that is displaying the first argument, which is 12, the second argument, which is 12 again, and the third argument, the response, which is the result, which is 24. So, okay. We can write another sample. Another good thing about a decorator is they can also take in arguments. Since they are functions, you can pass an argument to a decorator. It's just that when you pass in an argument, then the syntax changes a little bit. So let's assume we want to work on this, want to decorate this function, which is say Python, to display the name of the person that is saying it. So like if I should call the function, when I wrap it in a decorator, I should pass in my name, that is Bolaji, to it, and it tells me Bolaji said Python Nigeria. Well, what we'll be doing is similar to what we did before. The only difference is that like we are now going to be nesting more functions because we need a function that will take in the argument, a function that will take in the function, the actual function that we are passing into it, I want to extend, and the last function will now take in the arguments, just like what we have done here. So I will call that noun because I'm out of ideas, and I will give it name. Yes. So I've done something that is similar to what I did earlier. The only thing is that I have 3 functions that are nested inside each other. That is the only difference. The outer function is taking in the arguments, which the dictionary, which the decorator is taking. Then the second one takes in the function, and the last one takes in the argument. And all I'm just doing here is tell me the name of the person that wants to use that function and what the function does. Now, we are using the args here, argument, of which in this function, we are not passing in any argument, so it doesn't really matter. So let's try it now. Let me run this and this. Yeah, so it works. Passing my name as an argument to the decorator, and it works just fine. Yes. And that's the end of my presentation.